Hello everyone and thank you for joining us in this EMS webinar. In this webinar, we shall show you how to simulate a permanent magnet linear generator using EMS, right inside SolidWorks, and give you some design tips. Our agenda is as follows: a brief discussion about our products and services, followed by the main technical presentation. After the technical presentation, we will brief you about licensing, services, and various learning resources offered by EMWorks. Then comes the questions and answers period. At that point, Dr. Kabir will go on stage and answer your questions. You may then type your questions in the chat section. All of your questions will be answered. All of our products are integrated into SolidWorks, the #1 3D CAD package. Some of our products are equally integrated in Autodesk Inventor. Why? There are a couple of reasons, including, we want to concentrate our effort on what we know best. Electromagnetic simulation. We don't want to reinvent the wheel. In other words, why should we develop a CAD while there are excellent professional CADs? Developing a CAD requires much more human and financial resources than a simulation software like ours. Indeed, all simulation companies that made the mistake of developing their own CAD ended up with a primitive and even mediocre software. Why bother about learning a new primitive CAD? Just use your professional CAD and start simulating right away. You can easily collaborate with other departments in your company since all of you use the same CAD model. Some companies that have their primitive CAD claim that you can import files from popular CADs such as SolidWorks or Inventor. It is true, you can import. However, oftentimes you would need to heal, stitch, or clean the geometry because of compatibility issues. Furthermore, if and when you need to make the smallest modification, you must start all over again. We hope that you understand now why we stayed away from developing our own CAD and, instead, relied on the professional CADs. We believe that we convinced you. You may ask now, what are the other companies that provide an electromagnetic software package that are fully integrated in a professional CAD such as SolidWorks or Inventor? Look no further. EMWorks is the first and the only company that provides electromagnetic software as add-in to SolidWorks and Inventor. As a matter of fact, the integration in SolidWorks dates back to 2007 and in Inventor to 2012. Consequently, we have more products integrated in SolidWorks which are all gold certified. Our products and services are as follows. EMS is a 3D electric and magnetic field modeling software for frequency ranging from DC to few hundred megahertz. It covers many applications like insulators, cables, bus bars, permanent magnets, actuators, circuit breakers, transformers, and motors. EMWorks is an electromagnetic simulation software for RF, microwave, high frequency, and high-speed electrical and electronic devices. It covers many applications including a wide range of antennas, resonators, filters, connectors, and waveguides. EMWorks 2D is a 2D and axisymmetric electric and magnetic field modeling software for frequency ranging from DC to few hundred megahertz. It covers the same applications as EMS. Motor Wizard is a template-based motor design software. It offers analytical and finite element analysis for BLDC and permanent magnet motors. In addition to these solvers, we offer several multi-physics modules including motion, stress analysis, thermal analysis, electric circuits, and ECAD. Let's move now to the feature technical presentation.
Welcome again to this EMS webinar. Tips for Permanent Magnet Linear Generators Design. A permanent magnet linear generator is simply a generator made up of a stator, translator, and air gap. The stator is usually made up of copper windings and laminations which aim at minimizing the eddy current losses. The translator consists of permanent magnets that can be either rings, cylinders, or rectangles and made of rare earth material. Depending on the required force and the air gap magnetic field, the magnets can be arranged radially, axially, or in Halbach fashion. Numerous research papers have reported that the permanent magnet linear generator has several distinct advantages, including high efficiency, small air gap, and a small size. In addition, permanent magnet linear generator is environmentally friendly as it emits no CO2 and consumes no fossil fuel. However, there are several challenges and hurdles that must be overcome, including demagnetization of the permanent magnets due to temperature rise, high cogging force which can produce noise and vibration, and the high cost of the rare earth magnets. In this webinar, we shall show you how to use EMS and SolidWorks to simulate a permanent magnet linear generator and analyze the results thereafter. We will conclude the webinar by giving you some tips related to the simulated example and other general guidelines related to the design of permanent magnet linear generator. Since EMS is an add-in to SolidWorks, the number 1 3D CAD software, the creation and modification of the geometry is as easy as a pie. We shall give you a quick overview on how to create an EMS study and link it to a SolidWorks motion study. Then, we will analyze the results from several studies that have different materials or other input parameters. Before creating a SolidWorks motion study, make sure to activate the motion add-in as shown. Click OK. To create a motion study, right-click below the motion area as shown and choose Create a new motion study. Click on the motor's icon and choose Linear Motor or Actuator. Select the face of the translator as shown. Under Motion, choose Oscillating and enter 150 mm for displacement and 5 Hz for frequency. Click OK. Enter 0.3 seconds for the end time of simulation and zoom to fit. Click Play to pre-review the motion. Motion study is complete and ready to be coupled to EMS. To add a new EMS study, right-click on the project name and choose Magnetostatic. Give it the name of PMLG. Click on the Coupling Analysis tab and check Motion Coupling. At this point we are ready to couple the EMS study to the SolidWorks motion study. Under Motion Coupling, choose the desired SolidWorks motion study. Selected the moving components, which are the translator and the magnets. Under Band Component, choose the band, which is the air surrounding the moving parts from all sides. Please refer to EMS Help to learn more about the band. Click OK. That's it, and that's all it takes to couple an EMS study to SolidWorks motion. Let's apply the material for each body, as shown. The material for the air box and the band is air. The coil is obviously made of copper. The material for the magnets is N4212. The material for the stator and translator is steel 1010. The magnets have a strength and direction. To set the direction, right-click on a magnet part and choose Coercivity Direction. Choose the Y direction. Click OK. Alternate the coercivity direction between +Y and -Y for neighboring magnets. To add a coil, right-click on the coil's icon and choose Wound Coil. In selected entities, choose the bodies that make up the coil. Under Entry Port, select an interface, as shown. Under Exit Port, click Same as Entry Port. Click on General Properties tab and specify the AWG, the number of turns, and current per turn. Since all of the coils are passive, the current per turn is just 0. All the pre-processing is now complete, and we are ready to run the study. Right-click on the permanent magnet linear generator study and choose Run. Solving will take time. Let's instead examine existing studies that were run previously. We have the results for 6 studies. In studies 1 to 3, we kept the speed constant but changed the steel of the translator and stator. The steel for studies 1, 2, and 3 are steel 1010, silicon iron, and somaloy, respectively. In studies 4 and 5, we kept the material somaloy the same but changed the speed of the translator. Let's examine the results of study 1 in some details and then compare the results among the studies later. After the run is complete, Results folder is created and contains different type of results. Double-click on Results table to examine lumped circuit and mechanical quantities as well as motion results, including force, torque, back EMF, resistance, inductance, flux linkage, current, and energy for each time step or each motion position. All of the results table quantities are plottable as function of time or position. For example, click on the Fy force component and click Add in the Parameters field. Click on Pop-up Plot. The plot of Fy versus time appears. You may equally view the listing by clicking on its icon as shown, which you can save in different formats. Follow the same steps to plot any of the table quantities. For example, let's plot the back EMF for all the coils as shown. To plot the motion parameters, click Plot at the bottom of the table as shown. It shows the center of mass of the moving bodies as function of time. You may also plot the velocity and acceleration, as shown. To close the results table, click Close. The magnetic flux density and magnetic field folders contain the near flux density and magnetic fields in the entire model. From the magnetic flux density folder, we can create different types of plots: fringe, vector, streamline, and 2D plot. Right-click on the magnetic flux density folder and choose 3D fringe plot, no clipping. The magnitude of the magnetic flux density is color-coded, where the red color is the maximum and the blue color is the minimum. as shown on the legend on the right side of the plot. Click on different time step. The values change. Click OK. Right-click on the plot icon and animate, as shown. Right-click on the magnetic flux density folder and choose 3D fringe plot section clipping. Check Plot on Section Only. Click OK. Right-click on the section plot and animate versus time. Right-click on the section plot again and animate versus section, cut this time. Right-click on the magnetic flux density folder and choose 3D vector plot, no clipping. Check Show Plot Only on selected entities. Choose the translator. Click OK. Right-click on the vector plot icon and animate, as shown. Right-click on the magnetic flux density folder and choose 2D plot linear. In the graphic area, click on several points on the model, as shown. The magnetic flux density plot between segments appears. All the plot performed on the flux density can equally be applied on the magnetic field, applied current density, and force density. So much for the field plots. Under Electromagnetic Parameters, right-click on Tables and Table. From Parameter, choose Fy. Click Add. The table of Fy versus time appears. Click on 2D plot. The plot of Fy versus time appears. Follow the same steps to plot the back EMF. Last but not least, you may generate a report that summarizes all of your work. Right-click on Reports folder and generate. Customize your report and choose either HTML or Words format. Click OK. Let's now compare the results from different studies. From the root of the tree, choose Compare Results Motion Studies Magnetostatic. Uncheck all studies except the first three. Click on the Fy force component and click Add in the Parameters field. Click on Pop-up Plot. The plot of Fy versus time appears. Upon zooming, you can see that the maximum cogging force is around 1358, 1322, and 1222 for the silicon iron, steel 1010, and somaloy respectively. Follow the same steps to compare the back EMF. Unfortunately, the somaloy has the smallest back EMF while the silicon iron has the largest. It is a trade-off, as you can see. We can also check the effect of the speed of the translator on the back EMF. Check only the somaloy studies. Click on Back EMF and click Add in the Parameters field. Click on Pop-up Plot. The plot of the back EMF versus time appears for the 3 studies appear. By the way, somaloy study has a speed of 2 meter per second. Somaloy speed 2 study has a speed of 3 meter per second. Somaloy speed 3 study has a speed of 4 meter per second. From the plot, the maximum back EMF is around 93, 109, and 120 volts for speeds 2, 3, and 4, respectively. Clearly, the higher the speed, the higher is the back EMF. We can also compare the effect of the magnetization direction. All of the 6 studies have an axial magnetization along Y except the radial coercivity direction study has a radial magnetization direction, of course alternating between +ρ and -ρ. We can again compare the cogging force and back EMF. Following the same procedure. We can see that the cogging force is much smaller for the radial coercivity. However, the back EMF is also smaller. Again, it is a trade-off. Let's now conclude. The cogging force depends on the steel of the translator and the stator, the magnets and their coercivity direction. And so does the back EMF. In all of the studies we neglected the eddy current due to motion because the speed chosen is relatively low. Otherwise, eddy current must be taken into consideration. If and when the eddy current is included, the steel would heat up resulting in a temperature rise in the magnets which can potentially demagnetize them. The permanent magnet linear generator is an excellent candidate for power generation in ocean using the motion caused by the waves. Even though we did not study the effect of the air gap, but we expect that the smaller the air gap the higher is the back EMF and the cogging force. Hence the trade-off between cogging and power generated must be carefully studied. The arrangement of the magnets is equally important in reducing the leakage flux and improve the flux linkage. Although the generator produces AC voltage and current, the frequency and amplitude of the voltage changes with the speed, and this make it essential to use power electronic converters to maximize the power utilization. It is worthwhile to mention that even with a constant speed, the magnitude of induced voltage will not be constant. Therefore, power converter efficiency should be considered for determination of efficiency of the whole system. A tool like EMS is indispensable to design and optimize the permanent magnet linear generator. You cannot guess it. You must simulate it. Thank you for attending this webinar and hope to see in future webinars.
Thank you everyone for bearing with us. And I hope that you have learned from the feature technical presentation. Let me briefly touch upon the licensing structure offered by EMWorks. We offer 3 different programs: commercial, academic, and startup programs. Each program has its own benefits and requirements. For the commercial program, we offer perpetual licenses. Our licensing structure is usually annual based for the rest of the programs. We have a combination of free and paid licenses for students, academics, mentors, lecturers, and professors based on the program they choose. For startups, we offer a very interesting and generous program that saves you money for other startup expenditures. Learning resources. EMWorks offers you various free learning resources, a standard help and step-by-step tutorials, a demo viewer that gives you a head start by accessing many predefined examples and tutorials, regular webinar series on trending electromagnetic topics. Like today's webinar, we regularly post several application notes, blogs, and videos on our web page and social media channels. An annual user conference where you can exchange views and experience with other fellow users. Paid and free web and in-person training. Monthly newsletter to update you about the latest releases, webinars, and other activities. Support and services. Our support service is the strongest point that I can mention in this presentation. We always have your back before and after sales. We offer one-to-one web demo sessions to give you a head start and shorten your learning curve. You may even run a benchmark for you if you want to skip the trial option. We offer consulting and design engineering services. We may even propose to you a new design as per your requirement or refine and optimize your existing design. Featured customers. These are just few of our respected clients. These big names, that come from various industries, are true testimonial for the quality of our products and services. I encourage every one of you to try our software and experience its power and ease of use. We offer 2 weeks of free trial license. You may opt for a benchmark instead of a trial license. Please visit our webpage at www.emworks.com. Go to our Contact Us page. Fill in your information and submit your request. We will contact you promptly. On behalf of EMWorks, I would like to thank all of you for attending this webinar. Feel free to contact us after this webinar to get more information on our products. Now we pass to the questions and answers period. Please type your question in the chat section. I kindly request Dr. Kabir to go on stage and answer the questions.